Okay, in this example we're going to look and introduce the idea of the discriminant. Okay, and the discriminant is really useful in helping us determine whether or not something's easy to factorize or if we're just trying to get an idea about what it looks like when we graph it. Okay, so the first thing is important to note that the discriminant actually comes from our quadratic formula. So we know our quadratic formula looks like this. So that's it. Should go across there, divided by 2a. Okay, this is our quadratic formula, and actually our discriminant is this part here. Okay, and we call the discriminant, it's recognized by a triangle. So this is our discriminant. Alright, so let's have a look at three different functions, and we're going to use the discriminant to try and help us work out if there's only one solution, if there are two roots, or if there are no roots. Okay, so the first one we look at is, got this equation 2x squared minus 2x plus 3 equals 0. Okay, so that should be a minus. So I want to find the discriminant is equal to b squared minus 4ac, so negative 2 squared minus 4, this is a, and our c is 3. Okay, I can evaluate that. Hopefully we don't need a calculator, but maybe you will, and that equals negative 20. Okay, so I can see that my discriminant is less than 0. Okay, this ends up being a bit of a problem. We say over here, if my discriminant is less than 0, there are no, whoops, I wasn't meant to do that, there are no real roots. Okay, and you think about that, we can't have a negative here under this square root sign. So that's why there's going to be a problem if that happens. Okay, that's that first example. Okay. Okay, the next example we looked at goes, what we're going to look at is this. 3x squared minus 4x minus 2 equals 0. So same thing, let's try and find the discriminant. B squared minus 4ac, that's going to be negative 4 all squared minus 4 times 3 times negative 2. Okay, some quick calculations here, and we end up with 40. Okay, that ends up being 16 plus 24, and we get 40. So here, in this case, our discriminant is greater than 0. So if it's greater than 0, there are going to be two distinct, so that means sort of different, real roots. Okay, this idea of a root will make a little bit more sense in the next video when we actually sketch these functions. Okay? Okay, and the last one we're going to do is we're going to start with the function or the equation 9x squared plus 12x plus 4 equals 0. Okay, and I want to use the discriminant. The discriminant is equal to b squared minus 4ac, so that's going to end up being 12 squared minus 4 times 9 times 4. So this ends up 144. 4 times 9 times 4 is also 144, so what I end up here is 0. My discriminant is equal to 0. That means there is only one solution. We can also say that it has a repeated root. Whoops. Okay, a repeated root. And again, we're going to have a look at this idea of the roots in the next video when we have a look at functions. Okay, so there we saw three different examples of using the discriminant. Thanks.